All right, here's the chapter 8 solutions. I know we went over some of these when we met, but just so you see them. So first we just have some pretty standard factoring. So here I took out a GCF, and then I put each piece equal to 0. So 4x equals 0 gives me the 0, and x minus 5 equals 0 gives me the 5. Here I just did some regular factoring. I found the two things that multiply to 6 and add up to -5. There they are. And then I put each piece equal to 0. X minus 3 equals 0 gives me the 3. X minus 2 equals 0 gives me the 2. This one was a difference of squares. Okay, and then down here I was asked to factor something a little bit more complicated, so I found the two things that multiply to 12 but add up to 1, and they were 4 and -3. So I split that middle term into those two pieces, and then I take a GCF out of each half. So a GCF from here, a GCF from here, and then I write my solution to x minus 3 and x plus 2. I solve each piece. So when I put this equal to 0, I add 3 and divide by 2, and then this one gives me the -2. All right, this one I tried to factor, but I couldn't find two things that multiply to 30 and add up to -10. So a reminder, when it can't be factored, that's when we put it in the quadratic formula here, which I will write down quickly. Remember, that will be on your formula sheet, so that should help. B squared minus 4ac all over 2a. Number 6, we were asked to complete the square, so that's what I did. I first move the number, then I do half of the -4 and square it on both sides. So that gives me 12 here. Take the square root of both sides, and then I add the 2 to both sides. 7 and 8 are more complex and are not on the exam, so I'm not going to make you watch a video about it. Number 9, I was supposed to use the quadratic formula, so that's what I did. I put -b, so that's -1, plus or minus the square root of b squared minus 4 times a times c over 2a. Remember those invisible numbers, the 1 in front of the x squared and the 1 there. And then we just simplify. When it doesn't simplify anymore like this, we kind of just have to leave the 7 under the square root. But anytime there's a negative under the square root, I can take the I out. Okay, down to number 10. I just did the same thing again, stuck all the stuff into the quadratic formula. This one simplified pretty, so I ended up with the square root of 16, which is 4. So I do it twice. -6 plus 4 is 10 over 10. -10, sorry. Nope, -6. -6 minus 4 is -10 over 10. That's -1. -6 plus 4 is -2 over 10, which is -1/5. Number 11, I'm sticking it in there again, but this time I get, again, a perfect square, but a negative. So the square root of -4 is 2i. I can't simplify that very much, but I can take a 2 out of everything, so I did. Number 12 through 14, again, not on the exam, so I won't make you listen to that. Number 15, I just did the discriminant, which, remember, is the part under the square root. So it's the b squared minus 4ac. I plug it in. If I get a positive number, that means 2 real solutions. I did the same thing here, b squared minus 4ac. I got 0. That means there's 1 solution. If you get a negative, which is the only other option, that means there's 2 complex solutions. So number 17 is just a lot of multiplication, so I thought you just might want to see the answer really. But remember, the minus is part of the formula and it must go all the way through. So when I do x minus this, it's x minus 2 minus square root of 5. When I do x minus this, it's x minus 2 minus negative square root of 5, which is the positive. And then I multiply. The way I did it is I multiplied everything in the second equation by x, so x times everything. -2 times everything, -5 times everything. I don't pay much attention to it, I just write it down. And then I put my like terms together. I've kind of underlined them here. The -2x, the -2x make the -4x. These two cancel out, these two cancel out, and so on. I did it again here. This one's pretty simple. I'm sure you mostly got that one right. And then number 19 is pretty similar to number 17. So again, x minus 3 plus square root of 2 means x minus 3 minus square root of 2. It goes all the way through. Same here. And then I did x times each thing, -3 times each thing, negative 2 times each thing, which gives me 1, 2, 3, 4, 5, 6, 7, 8, 9 terms if I've got them all. I expect all of the square roots to disappear because those are conjugates, so all the square roots should disappear if you've done it correctly.